In this video, I'll be describing a geometric model. It consists of two shapes that are formed by packed spheres and represent voids between these spheres. This is a tetravoid, which really is formed by four packed spheres. As you can see, it would consist between these four spheres. And the octavoid show here is created by six spheres packed together in this configuration, and the void would exist inside these spheres. The voids have magnets embedded in them, so it allows a tetravoid to connect to an octavoid, but it won't allow two of the same to connect to each other. And these modules can be joined together in various ways to create various shapes. I'll show a couple simple ones right here. Now this is starting to form a half a sphere. You can see the sphere fits in this quite well. If I add another 7, it's an identical shape, basically it'll enclose the whole sphere. And this shape itself here, you can see, will resemble an octahedron. I can show you here very quickly with some outer shelves. You can see it's starting to take the shape. And that's an occurrence of an octahedron. And another simple shape can be created here. And this now sort of is a tetrahedron. Maybe a little clearer if I add in some sides to it. And that's just a basic tetrahedron when these voids are connected together. Now let me describe the underlying framework that gets created as these voids are connected together. At the center, you see there's a spherical enclosure. I can put a sphere in there right now. And around the periphery you can see where the beginnings of spherical enclosures are created. And as I add more of these voids, I'm going to use a submodule here that I can attach, and then I can start adding in some spheres and start adding in some of these other structures. And that'll hold those in place. So let me add a few more. Squeeze one in here, and one in here. So now you see I've created an array of spheres, and that's an FCC arrangement. So the other thing I've done is can employ an optional element to this model, where you see on the top of this point of the tetrahedron, I can put a little wedge in the top there to basically fill in that space where the sphere would have been. And in fact, if I take a tetravoid and basically add in some of these tetra wedges, you might see more clearly And now it takes on the shape of a tetrahedron. Now we can do something similar with the octavoids. Again, at the top of this octahedron here, we can fit in a wedge, a sphere. And that fills in that gap. And if I do this for a octavoid here, I can add in 6 wedges. And this will starts taking the shape of the octahedron. And now these can be used optionally in your construction as well. So you've seen this shape before, the basic tetrahedral shape made out of these voids. Well, let me show you how this looks if we include the wedges. We would first have the octavoid with its 6 wedges included, and then the tetravoids and its wedges are added on. Now you can see more clearly the tetrahedron and basically the spheres that are stacked together within this module. Now you've also seen this shape before. This is basically the octahedral shape made from the voids, but I'm going to show you the same thing with the wedges included. We start with the octahedron. And now that forms your octahedron, like you saw here originally. And we can also take these shapes and rearrange them. Now that becomes just a larger occurrence of the octahedron, as well as you can see the various spheres that would have fit inside this octahedron. In this video I'm just going to transform this shape by replacing the octavoids with the versions that have their wedges included, like this. And this will be another shape that I'll try to transform by just using the tetrahedrons with their wedges included. Now I'm going to show you how to build up some more complicated structures using an octavoid with some octawedges connected, as well as some of these tetravoids with some tetrawedges hooked up. This will also now allow me to add in spheres in these voids.